Hello dear students, welcome to Pen and Paper Chemistry. We are continuing with our properties of haloarenes and this is part 4 in the set of videos on the topic. Before we begin with the lesson, a simple earnest request is to grab your pen and paper in order to be able to write the reactions that we are going to do in this video and the others as well. Please. We had classified the properties of haloarenes under 4 subheadings. So, we had electrophilic substitution, nucleophilic substitution, reduction and miscellaneous reactions. And today in this video we shall be talking about reduction and miscellaneous reactions as we have already covered the other 2 subheadings. By the end of this video, you would have also completed this flow chart which will help you to remember as well as recall haloarenes at a glance. I hope you are continuously adding the products of the reaction to this chart paper. So, we have haloarenes and we are going to talk about reduction of haloarenes. Now, reduction, you've talked about many reducing agents. For haloarenes, we can use nickel aluminium alloy with an alkali, sodium amalgam in an aqueous solution, or lithium aluminium hydride. LAH stands for lithium aluminium hydride as the reducing agent. So, we can simply write the reaction as C6H5Cl plus, you can represent it by nascent hydrogen. Please write the 3 reducing agents which we have mentioned, and of course, the product of reduction is C6H6 benzene plus HCl. Simple? Try changing the Cl to, let's suppose you take it as C6H5Br. Try writing the same reaction with all the 3 reagents listed. You don't use all 3, you use any one of the 3. Write the product of the reaction. So, that will increase your and improve your command over the subject and also increase your confidence. That is why I am saying, please write. There is no point in watching this video alone. You are not going to be really gaining something out of it. You may feel happy, oh I know this, yes, this is what I have done. But unless and until you write, you will still feel some important factor missing, and I am sure you don't want to do that. Next we come to the words fatigue reaction. Now words fatigue reaction, if you notice, this is a word which is very familiar to us from haloalkanes. How is it familiar? Now if you can recall the words reaction very well. If you can't, then pause the video, think about it. I'll give you the hint over here. It's a reaction which helps you to double the number of carbon atoms. So, if you start with an alkyl halide with 1 carbon, you end up with the product having 2 carbon atoms. So, it helps you to double the number of carbon atoms. You start with an alkyl halide with n carbon atoms, you end up with a product having 2n carbon atoms. Think about it. It's the first, almost the first reaction you do under alkanes. It's one of the preparation of alkanes. Yes, you got it right. So, what do we have here is CH3Br plus sodium in dry ether. What does it give you? The reaction gives you CH3CH3, 2 alkyl bonded to each other and NaBr. Now students usually find it a little difficult to remember. So what do we tell them is, okay, Write two molecules of bromomethane, CH3Br, CH3Br. Do we put a line between them? No, we don't put a line between them. This is not one molecule. This is basically two molecules of the same compound, CH3Br. So you have to be careful. Why I am saying this is because in my experience, I have seen students drawing a line indicating a bond between them. No, that is wrong. So please don't do that mistake. Now next step is write a 2 over here, make a small box, and we will have NaBr, so 2 NaBr and CH3.CH3. Now is there a single bond? Yes, there is a single bond, because what happens over here is the two alkyl groups bond with each other to give us, what compound is this? Think about it. Yes, perfect. This is C2H6. This is called ethane, right? Okay, what if I have to form butane? Think about it. So if I want C4H10, okay, what are you going to start with? If you notice, one carbon atom over here becomes 2. So if I want 4, how many will I take over here? Very good. I will take 2, C2H5Br. Write the reaction yourself then, C2H5Br, that means 2 molecules. Some students also prefer to write the reaction like this, where they'll write a 2 in front of it, sodium and dry ether. You have to see how you are comfortable and how you can remember and recall easily, right? NaBr once again. Now why am I explaining this concept here? Because what we are going to do is, Wurtz-Fittig is again a reaction like this. And what is this reaction type? It's a coupling reaction. They formed a couple, right? Two molecules have coupled together to give you a single molecule. We are going to carry out this coupling reaction using aromatic halides as well. So let me write it as C6H5Cl, right? And let me take C6H5Cl plus Na in dry ether, form a couple, and there we go. Here we have NaCl, and we will have C6H5, a single bond C6H5. You want to visualize this product? It is like this. It is 2 molecules of benzene. Now 2 molecules of benzene, out of which the hydrogen has been removed, and they form a bond with each other. You've got a benzene, you remove a hydrogen from it and it becomes phenyl, right? So now what is this product that we've got? We've got biphenyl, right? C6H5 becomes phenyl. So we've got over here C6H5, single bond C6H5, that is biphenyl. This reaction is known as Fittig reaction, right? It's a modification or the application of the Wurtz reaction to aromatic compounds. Now, can we form a couple between an aromatic halide, taking an aromatic halide? Yes, you can put a plus sign over here in order to avoid confusion. And let's say an alkyl halide. Let's try it. Yes, literature tells us that yes, we can again carry out this reaction. And what do we get over here? Again, NaCl. What will be the product? C6H5CH3. In order to visualize it, draw it like this. So we have the phenyl and we have the CH3 group attached to it. Correct? So this becomes, you can call it as methylbenzene according to the IUPAC system, or as I mentioned in the earlier video, in the case of aromatic compounds, their common names are also quite popular. So this is what we've got is toluene, right? Interesting. So are we ready to complete our chart? And what will you call this reaction as? Because I'm using an alkyl halide, so Wirtz reaction? No, but the aromatic halide says I undergo a reaction called as Fittig reaction. So let's make them happy and let's call it as Wirtz-Fittig reaction. It's a coupling reaction involving an aromatic halide and an alkyl halide. Interesting. So from one reaction which we knew already, we have formed two more reactions. So would you like to complete this chart now? So what I've got over here is Wirtz-Fittig reaction. So what I'm going to do, yes, put an R over here. So I've taken sodium, alkyl halide and dry ether. Fittig reaction. So we've got a haloarene, sodium and an aromatic halide, and they undergo a single bond and we get biphenyl. What's the next reaction we've got? Again, I am going to go back to what we've already done. C2H5Br treated with magnesium. What does it remind you of? C2H5MgBr, an important set of organic compounds, what we call as Grignard's reagent, right? I have missed out something in this reaction. Absolutely. What is the condition of this reaction? Go ahead, find the condition of this reaction for me. I'm not giving it to you. We've already discussed it under the properties of haloalkanes, right? We are going to extend the same reaction to aromatic halides and we will have C6H5Br, right? So aromatic halide, we need a solvent for it. So the solvent in the case of aromatic halides that we use is tetrahydrofuran, dry tetrahydrofuran, THF. So instead of C2H5Br, what will we have over here? Absolutely C6H5MgBr. So again we've got the Grignard's reagent over here. Would you like to complete this here? C6H5MgBr. I repeat, we are not doing the mechanisms of all of them. It's not warranted or it's not required by the syllabuses, by the curriculum that we are covering over here. Last but not the least. Why not the least? Because you may add or delete reactions from this flowchart as per your curriculum. In case there are any reactions followed by your curriculum, please feel free to add them to the flowchart. But draw these flowcharts. They are very, very helpful. Trust me, they are really useful for students towards when you are approaching your exams. For example, in some of the curriculum, they also teach a variation of the Fittig reaction, also called as the Ullmann reaction, where we have benzene, iodobenzene, on being heated with copper gives you biphenyl. So if you would like to add it to your knowledge base, please feel free to add this reaction to the flow chart. Chloral. Reaction with chloral in the presence of excess concentrated H2SO4 is our last reaction we are talking about, which gives us an important compound called as DDT. So let's write down the reaction and the product. Now DDT is dichloro-diphenyl trichloroethane is the common name of this compound. We've all heard about DDT being used as a mosquito spray, right, to get rid of mosquitoes. So, because it's its common name, let me try and decipher its structure from its name only. So, if there are diphenyl means definitely I am bound to have two phenyl groups over here. Dichloro, now these two chlorine could be on any, but because I am talking about haloarenes means something like this, right? Dichloro-diphenyl. Trichloroethane. Now trichloroethane. Now ethane is C2H6, right? Or let me put it more simple. Ethane is C2H6. Now trichloroethane means I will have 3 hydrogen replaced by 3 chlorine, right? Something like this. So let's see. So we will have CCl3 and there'll be a carbon over here. Let's form a bond, right? And there we go. Correct. 1, 2, 3, 4. Yes, this was actually, oh, we are there, you see. This was the structure of dichloro-diphenyl trichloroethane, the DDT, the dreaded DDT for the mosquitoes, which is used as an insecticide. Right now, don't you think it's odd to be calling it like that? Because if we have to give its IUPAC system, name according to the IUPAC system, it would be different. Also, let's study how is it formed. Now, because we know that we need the chlorobenzenes over here, so definitely, boss, let's put the chlorobenzenes here. Now, because we are using concentrated H2SO4 means there is some removal of water happening, right? So, probably a hydrogen from here, which is in the benzene ring. That means there should be an oxygen. But we are talking about ethane, right? So, how about putting a CCl3 CHO? What does it become? Oh, yes, this is trichloro 222. So we'll name this number 1 and 2. So this would be 222 trichloroethane, right? So 222 trichloroethane, and there is the removal of water from here. Okay, no, you can't form molecules like this by hit and trial. This is just my way of trying to make it interesting for you and helping you to recall easily with the help of this simple, easy to remember technique. That means going in the reverse way, because I have seen many students struggling with this molecule or struggling with the formation of this. So here comes our aromatic halide, in the presence of concentrated H2SO4, and we have DDT. You know, its present name, its earlier name was, in fact, of course, this is the common name. Earlier name was something like 2,2-bis, something like parachlorophenyl 1,1,1-trichloroethane. But then there are new IUPAC rules, and according to the new IUPAC system, the name of DDT is 1,1-2,2,2-trichloroethane 1,1-diol bis 4-chlorobenzene. Yes, the name with all the attachments to it, right? It's a very short name, easy to remember, isn't it? By the way, DDT is known, or it has been found to be harmful to humans as well as other animals. In fact, it is believed to be a carcinogen when taken in large quantities. That is why its use has been discontinued in many countries, because it is harmful to the health of the humans. So, do you have this chart complete now for today? Keep it near your study table or your study area. Make it, draw it completely, draw the structures and keep it near your study area. Go through it 2 to 3 times in a day. Take one compound at a time. Try recalling the reactions, play it or do it like a quiz with your friends and classmates, and you will find that you'll be much more comfortable with organic chemistry. And if you combine the preparation of haloarenes with the properties of haloarenes, this is the kind of chart that you will have available, complete, where on the left hand side we've got the preparation and on the right hand side we've got the properties of haloarenes. You will be able to derive maximum benefit out of this flowchart only if you have been following all the videos that have been posted on the channel covering the preparation as well as the properties of haloarenes. Yes, I have not written the complete products over here. Please write down the complete product. So if you have Cl, we are talking about halogenation. So we will have the ortho and the para products, right? Same way nitration. Please complete this flowchart. This is yet not done. I don't want to give you ready-made stuff. Try it, complete the reactions, follow the channel. We have covered each and every reaction on the channel. A small request to all of you, if you have felt benefited by watching the videos on this channel, request is to share. Please share your happiness. Let us bring about more happiness around us by sharing the joy of learning in an easy and relaxed way. Happy learning to all of you. Stay safe.